Most people meet the Nile through a single claim: longest river in the world. That is true in length terms, but it misses the central point. The Nile's importance is not just that it is long. Its importance is that it creates continuity where geography would otherwise produce separation. It runs north through northeast Africa and empties into the Mediterranean, linking very different ecological zones into one connected human corridor. In wet tropical and highland regions upstream, rainfall feeds tributaries. Far downstream, in largely arid zones, that upstream water becomes the foundation of life. So the Nile is less a passive watercourse and more a transfer system. Climate in one place supports agriculture, settlement, and state survival somewhere else. That kind of dependency creates deep historical consequences. River behavior influences food supply influences political stability, and stability shapes institutions. The Nile also embodies a paradox. Compared with high-volume rivers like the Amazon, it carries less water, yet its strategic value is enormous because surrounding landscapes are often dry and alternatives are limited. In a desert context, a reliable channel has outsized weight. That is why the Nile keeps appearing in history, economics, and diplomacy. It is a geographic feature, but also an organizing force that determines who can grow food, where cities can expand, and how power is negotiated across borders. To understand the Nile properly, you have to understand that it is assembled from two major tributary systems with distinct roles, the White Nile and the Blue Nile. The White Nile is longer and often treated as the headwaters branch, beginning near Lake Victoria and flowing through Uganda and South Sudan. The Blue Nile begins at Lake Tana in Ethiopia and moves into Sudan from the southeast. They meet at Khartoum, and from that confluence northward the unified stream continues as the Nile. But length and volume are not the same thing. The White Nile contributes continuity and baseline flow over long stretches, while the Blue Nile contributes a much larger share of the total water volume, especially in seasonal surges tied to Ethiopian rains. This distinction matters because downstream stability depends on both reliability and magnitude. A long branch without major volume cannot fully sustain downstream demand, while high seasonal volume without continuity can create volatility. The Nile's structure is therefore a balance between these hydrological personalities. It also explains why modern policy disputes are so sensitive. When one country modifies storage or release patterns on a major tributary, it can alter risk conditions far beyond its borders. The river appears singular on maps, but in practice it is a coordinated outcome of separate climate systems, elevations, and national territories. After Khartoum, the Nile runs through the Nubian desert toward Cairo, then fans into a delta near Alexandria before reaching the Mediterranean. This route tells you why the river's influence became so concentrated. In many places, human settlement could not spread uniformly across wide fertile plains because the surrounding land was too dry for intensive agriculture without major infrastructure. Instead, population and cultivation clustered near the river channel. That concentration made the Nile Valley a narrow but highly productive strip with unusual political properties. Where productive land is linear and bounded, administration can become more centralized, collecting grain, collecting taxes, moving officials, and coordinating labor are easier when the main productive zones align along one transport corridor. The river also functioned as a logistical spine, enabling movement of goods and information between distant settlements. Then comes the delta, where the river slows, splits, and deposits material in a broad lowland before entering the sea. Deltas are fertile but fragile. Their long-term stability depends on continued sediment delivery and balanced hydrology. So even as the delta offered agricultural abundance and maritime access, it remained vulnerable to changes upstream. That duality is a recurring Nile pattern. The same system that creates prosperity can become a source of systemic risk if flow timing or sediment transport is disrupted. Geologically, the Nile in its present course is relatively young, having followed this broad path for around 15,000 years. That is long enough to shape civilizations, but short in deep earth terms. Its drainage basin extends across 11 countries, including states that contribute rainfall-rich headwaters and states that depend heavily on downstream withdrawal for survival. Much of the river's water ultimately comes from precipitation in upstream countries such as Ethiopia, Kenya, Tanzania, and Uganda. Downstream, especially in Egypt and parts of Sudan, local rainfall is limited, so river flow is not just useful, it is foundational. Other basin countries, including South Sudan, Burundi, Rwanda, the Democratic Republic of the Congo, and Eritrea, add complexity through partial basin overlap and varying hydrological contributions. This means Nile governance is inherently transboundary. National borders do not align with water generation, transport, and use. A dam, irrigation expansion, or drought response in one jurisdiction can alter agricultural and energy outcomes in another. This structural mismatch between hydrology and sovereignty is one reason Nile politics are persistent rather than episodic. The river cannot be fully governed through unilateral logic because the basin behaves as an interconnected system. Effective management requires data sharing, negotiated expectations, and mechanisms for handling dry years, not just wet year optimism. The Nile's foundational role in ancient Egypt is often summarized as simple flood fertility, but the implications were much broader. Annual flooding deposited nutrient-rich silt on riverbanks and floodplains, replenishing soils and supporting crop production in a landscape that would otherwise be agriculturally constrained. That recurring fertility allowed more than subsistence. It enabled surplus. Surplus enabled specialization, and specialization enabled administrative, religious, technical, and architectural complexity. When food systems are stable enough, societies can sustain non-farming roles at scale: scribes, builders, soldiers, officials, artisans, and priesthoods. In this way, hydrology translated into state capacity. The flood cycle also synchronized social time. Planting, harvesting, labor obligations, transport planning, and taxation could be coordinated around known seasonal rhythms. The river became a natural calendar and an economic clock. It supported communication and governance across distance because movement along the corridor was practical relative to overland alternatives in arid terrain. So the Nile did not simply support a civilization from the outside. It shaped the internal mechanics of how that civilization functioned. Administrative reach, political legitimacy, and social order were all tied, directly or indirectly, to managing and interpreting river behavior. The famous monuments are visible outcomes of a much deeper ecological and organizational relationship. An Egypt-only Nile story is incomplete. South of the Second Cataract, Nubia hosted powerful cultures such as Kerma and later the Kushite Empire, each deeply connected to river dynamics and regional exchange networks. The Nile corridor through Nubia was not peripheral, it was strategic. Control over movement points, trade passage, and river-adjacent settlement gave Nubian polities leverage in interactions with northern and southern neighbors. Cultural exchange moved both ways: technologies, artistic forms, political ideas, and religious practices crossed boundaries through conflict, diplomacy, and commerce. This reminds us that river systems do not create isolated civilizations by default. They create contact zones. Along the Nile, contact could mean competition over resources, but it also meant transfer of skills and institutions. In the modern era, river-connected lifeways remain diverse. Nilotic communities, including semi-nomadic cattle herders, have long adapted movement patterns to seasonal flood and pasture conditions. Their practices show another dimension of Nile dependence, not just settled agriculture and state infrastructure, but mobile ecological adaptation. This matters for current policy because large hydraulic interventions can affect both fixed and mobile systems. Development plans that focus only on urban electricity and irrigation may miss the social costs borne by communities whose livelihoods are calibrated to older seasonal rhythms. In the 19th century, European fascination with locating the Nile's source transformed the river into an object of imperial geography. Expeditions around Lake Victoria were framed as discovery, yet local societies already possessed practical environmental knowledge of these waterscapes. What changed was not the river itself, but the global power context in which knowledge was produced and circulated. Mapping, measuring, and classifying the Nile became tools of influence. Once river systems were represented through external cartography and survey science, they could be folded into colonial planning, strategic competition, and legal framing. This phase helped shift Nile governance toward formal technical administration, hydrographic data, engineered interventions, and treaty language gained prominence. It is important to read source-hunting narratives critically because they often erase indigenous expertise while exaggerating outsider novelty. Still, the long-term impact was real. The Nile entered a modern regime where control was increasingly mediated through institutions claiming scientific neutrality but embedded in unequal political structures. That legacy still shapes debates today. Contemporary disputes over flow, storage, and rights are argued with technical models and legal references partly inherited from this era. So the history of exploration is not a side story. It is part of how the Nile became a modern geopolitical system where knowledge, infrastructure, and sovereignty are tightly linked. In the modern period, especially from the late 20th century onward, dam construction across the Nile basin accelerated to support irrigation and generate electricity. More than a dozen major projects changed how water is stored and released. These dams delivered significant benefits in many contexts. Regulated flows can reduce certain flood risks, improve dry season water management, and stabilize power supply for homes, industry, and public services. For governments facing population growth and rising energy demand, these gains are politically and economically compelling. But dams redistribute environmental effects across space and time. Reservoirs trap sediment that once moved downstream, alter seasonal flow patterns, and can change aquatic habitats. Large projects may also trigger displacement of communities near inundation zones and force difficult compensation or relocation processes. So the real policy question is not a binary of development versus nature. The question is distribution: who receives electricity, who loses land, who bears ecological risk, and which trade-offs are temporary versus permanent. On the Nile, this distribution is transboundary as well as domestic. A project framed as national modernization can create downstream adjustments in farming costs, shoreline dynamics, or water reliability. That is why infrastructure on the Nile is always both engineering and governance. Concrete structures become long-term political commitments with basin-wide consequences. Sediment is often overlooked in public discussion, yet it is central to the Nile's long-term ecological and agricultural performance. Historically, annual floods transported nutrient-rich silt that replenished fields and helped maintain delta landforms against marine erosion. When major dams trap sediment upstream, less reaches downstream floodplains and the delta. Over time, this can reduce natural soil renewal and increase reliance on artificial fertilizers. It can also weaken delta resilience, making coastlines more vulnerable to retreat and saltwater intrusion, especially under rising sea levels. This demonstrates why river health cannot be judged by water volume alone. Two flow regimes with similar annual totals can produce very different outcomes if one carries sediment and seasonal variability while the other is flattened and sediment-starved. The Nile's older flood pulse was disruptive in some years, but ecologically generative. Modern regulation improves predictability, yet can degrade downstream geomorphic support systems that evolved around periodic replenishment. Future planning therefore requires integrated metrics: flow quantity, timing, sediment transport, soil fertility, and coastal stability must be evaluated together. If policy focuses only on reservoir levels and megawatt output, it can miss slower-moving structural losses that eventually become expensive crises. In the Nile context, sediment management is not technical detail. It is strategic necessity. The most visible contemporary tension is the dispute architecture around large projects such as the Grand Ethiopian Renaissance Dam and the longer legacy of major downstream regulation systems like the Aswan High Dam. Ethiopia emphasizes sovereign development rights and hydropower as a pathway to economic transformation. Downstream, especially in Egypt, concern centers on water security under extreme dependence in an arid setting where alternatives are limited. Sudan's position has included both potential benefits and safety or coordination concerns. At the technical level, negotiations focus on reservoir filling pace, drought year release principles, data transparency, and emergency operating procedures. But these technical files sit on top of a deeper political challenge: trust. Basin actors are asked to cooperate under conditions shaped by historical asymmetry, domestic pressure, and climate uncertainty. In wet periods, compromise seems easier. In dry periods, fear rises and narratives harden. That is why robust governance needs adaptive frameworks rather than one-time fixed formulas. Agreements must function under variable hydrology, not ideal conditions. Shared monitoring, joint scenario planning, and contingency rules for drought are not diplomatic extras. They are the architecture that prevents water stress from becoming broader regional instability. On the Nile, durable peace is increasingly tied to whether states can design institutions as dynamic as the river system they share. The Nile ultimately teaches a global lesson about civilization under constraint. For millennia, this river enabled dense human organization across landscapes where rainfall alone could not sustain large populations. It supported agriculture, trade, governance, and cultural exchange, but always through a precarious balance between natural variability and social coordination. Modern technology has expanded our ability to regulate water, yet it has also intensified interdependence. More control in one segment can produce more vulnerability in another if governance does not keep pace. That is the core Nile challenge now: aligning national development goals with basin-wide stability in a climate era defined by uncertainty. The future will not be secured by slogans about historical rights or unilateral modernization alone. It will depend on institutions capable of handling drought shocks, sediment realities, demographic pressure, and shifting energy needs without collapsing trust. In practical terms, that means data-sharing norms, negotiated flexibility, and long-horizon planning that treats ecological function as economic infrastructure, not background scenery. The Nile is still doing what it has always done, connecting distant societies through shared dependence. The question is whether those societies can convert dependence into cooperation. If they can, the river remains a lifeline. If they cannot, the same lifeline can become a fault line. If you found this helpful, please like this video and subscribe for more explainers.